Assalamualaikum warahmatullahi wabarakatuh. Previously, I would like to thank all the committees who have given me the opportunity to present the results of the research that I have done under the title How are students' spatial intelligence for geometry problem solving? And the first slide is introduction. 1 is definition of problem solving. Problem solving is the ability to get the right answers to unknown problems and has a degree of difficulty synthesis using knowledge from previous experience. And the point 2, the importance of problem solving. The problem-solving skills become an important aspect in students' lives, especially in the mathematics learning. And point 3, indicator of problem-solving. Indicators of problem-solving ability is understanding the problem, create a completion plan, implementing the plan, summing out the answer. Then the definition of spatial intelligence. Spatial intelligence is the person's ability to recognize an object or pattern accepted by the brain to describe. The importance of spatial intelligence for geometric problem solving. To study geometry materials, spatial intelligence is needed. This study aims to describe how students' spatial intelligence levels in solving geometry problems. Next, research method. 1. Research type. This study used qualitative research type with descriptive design. And participants, the study used 3 subjects using height, medium, and low spatial intelligence level. The subject is selected using purposive sampling techniques. And instrument, the study used spatial intelligence tests, geometric problem-solving skills tests, and structure interviews. The instruments of geometric problem-solving and interviews are validated by 3 experts in mathematics, while spatial intelligence test instruments are validated by 4 experts in psychology. The data collection and analysis. The data collection techniques used in this study include spatial intelligence tests, geometric problem-solving tests, and structure interviews. In the study, spatial intelligence tests were used to categorize students' spatial intelligence based on the grades they had obtained. Problem-solving geometry tests were used to explore students' problem-solving skills, and interviews were used to confirm student problem-solving test answers. And the data collection, and the data analysis techniques used in data reduction, data presentation, and conclusion. And the triangulation conducted in this study is triangulation techniques that are by comparing the test results of students' problem-solving skills and interview results with students. Next, result and discussion for S1 subject. And figure 2 is the result of the work of subject S1. From Figure 2, it can be seen that the subject of S1 is able to identify what is known and identify what to look for. Then, subject S2 creates a mathematical expression with mathematical symbols. From the symbol that has been written, the subject S1 is in a hurry to create a plan for completion with mathematical formulas. After the plan is made, then the next step taken by the subject S1 is to implement the plan, and has been made by doing the calculation correctly and precisely. In the process of calculating, the subject S1 performs precisely. The last step taken by subject S1 is to draw a conclusion. In Figure 2, it can be seen that the subject of S1 can make a precise conclusions to interpret the answer that has been obtained. Thus, the subject of S1 can be said to have met all the problem-solving indicators. Next, result of S2 subject. Figure 3 is the result of the work of subject 2. From Figure 3, it can be seen that the subject of S2 is able to identify what is known and identify what to look for. Then subject S2 creates a mathematical expression with mathematical symbols. From the symbol that has been written, the subject S2 continues by making a plan completion with mathematical formula. After the plan is made, then the next step taken by subject S2 is to implement the plan, but in the calculation there is a problem of understanding the concept, where the root number changes to a decimal number. Of course, this is a problem that needs to be fixed by teachers, because misconceptions cannot be left alone. In the process of calculating, the subject S2 performed precisely. Subject S2 also did not make a conclusion from the calculation results. Thus, the subject of S2 can be said to meet only a portion of the problem-solving indicators. And result of S3 subject. Figure 4 is the work of subject S3. Subject S3 is a student with low spatial intelligence, which is also seen from the student's answer about solving geometric problems, where the subject of S3 writes only a little of what is known in the problem. Then, the subject S3 does not write what to look for and what plan to use. The calculation and implementation process of the plan is also not written by subject S3. Thus, it can be said that the subject S3 does not meet the problem-solving indicators. The discussion in the given indicators have classified certain properties and the problem-solving capabilities of subject S1, S2, and S3. The similarity between each level of the subject is they both meet each stage of the research. However, each subject meets different indicators, where students with high spatial intelligence have better problem-solving skills compared to students with moderate and low intelligence, where students with moderate spatial intelligence have better math skills than students with low spatial intelligence. Students with moderate spatial intelligence have made appropriate steps but make mistakes in the final result where there is a misconception. From the result of interviews conducted by research to the subject as to can be known that ignorance of the concept of encouraging to make mistakes. Problem-solving activities relate to the student experience, so that the things taught by the teacher are very important in the problem-solving process. Students with low spatial intelligence cannot deform problems into geometric shapes. This is because transformation and skills are common mistakes that students make due to the incomprehension of their students to choose the procedures to be used in problem solving. Students with low spatial intelligence tend to make more mistakes, including transformation, encoding, and process skills. The following is an excerpt of an interview that research conducted on the subject 3. From the results the interview it can be known that the subject S3 cannot answer the problem given because of the difficulty to identify what to look for so that in the next process is deadlock. And last, the conclusion. From the data and discussion presented by the research, the conclusion in this study is that students with spatial intelligence have better math problem solving compared to students with moderate and low spatial intelligence. Students with high spatial intelligence meet all the indicators given. Students with low spatial intelligence have not completed all the indicators given, while students with low spatial intelligence only explain a little of the indicators that have been given. Thank you for attention. Wassalamualaikum warahmatullahi wabarakatuh.